Unraveling the Storms, the Vital Role of Meteorology. Written by David Attenborough, Planet Earth. Meteorology is the study of the atmosphere. It helps us understand weather patterns. These patterns determine if we have sunshine, rain, or storms. By understanding the atmosphere, we can predict the weather. Accurate weather prediction is crucial. It keeps people safe from dangerous storms. It also helps farmers plan for planting and harvesting. Meteorology plays a critical role in our daily lives. Birth of a tempest. The formation of a storm is a mesmerizing yet daunting natural phenomenon. Cyclical, frontal, and low-pressure systems. These systems are the backbone of our understanding of weather patterns and storm formations. Storms are powerful forces of nature. They can manifest as hurricanes, tornadoes, or even simple thunderstorms, each with its own unique characteristics and impacts. They form due to various atmospheric conditions. The transition from a calm, sunny day to a turbulent, stormy one is a complex process influenced by multiple factors. Let's explore some prominent theories behind their formation. Understanding these theories helps meteorologists predict and prepare for these natural events. Cyclical theory suggests storms follow repetitive patterns. These patterns can be observed over time, providing valuable data for weather forecasting. These patterns are influenced by the Earth's rotation and solar radiation. The interplay between these elements creates a dynamic environment where storms can thrive. Frontal theory explains storms arise from the collision of air masses. When different air masses meet, the resulting interaction can lead to the development of storms. Warm, moist air clashes with cold, dry air, creating instability. This instability is a key ingredient in the formation of powerful storms. Low-pressure system theory focuses on areas of low atmospheric pressure. These low-pressure zones are often the breeding grounds for storms. These areas draw in surrounding air, leading to rising air currents. As the air rises, it creates a vacuum effect, pulling in more air and fueling the storm. As the air rises, it cools and condenses, forming clouds and precipitation. This process is essential for the development of rain, snow, and other forms of precipitation that accompany storms. Understanding these systems not only helps in predicting storms, but also in mitigating their impacts. By studying cyclical, frontal, and low-pressure systems, we gain insights into the intricate dance of atmospheric forces that shape our weather. The butterfly's wing-beat chaos theory and the unpredictable nature of weather. This concept is a fascinating intersection of mathematics and meteorology. Chaos theory in meteorology centers on the interconnectedness of atmospheric variables. These variables include temperature, humidity, wind speed, and countless other factors that interact in complex ways. Even small changes in initial conditions can have significant consequences. For instance, a slight variation in temperature or a minor shift in wind direction can drastically alter weather patterns. This is famously known as the butterfly effect. The term was coined by meteorologist Edward Lorenz, who discovered that tiny differences in a dynamic system could lead to vastly different outcomes. A butterfly flapping its wings in Brazil, theoretically, could influence the formation of a tornado in Texas weeks later. This illustrates how interconnected and sensitive our atmosphere is to initial conditions. This interconnectedness makes weather inherently unpredictable. Despite advances in technology and modeling, the chaotic nature of the atmosphere means that long-term weather predictions are fraught with uncertainty. Long-term forecasting remains a challenge due to the complex and chaotic nature of the atmosphere. Meteorologists use sophisticated computer models and vast amounts of data, but even these tools have limitations. The ever-changing variables and their interactions make it difficult to predict weather with absolute certainty beyond a few days. Our changing climate, global warming, and natural variability. Climate science investigates long-term weather patterns. It helps us understand global warming and natural climate variability. Global warming theory suggests human activities are increasing greenhouse gases. These gases trap heat, leading to rising global temperatures. Natural variability encompasses fluctuations in climate caused by natural factors. Volcanic eruptions and solar cycles are examples of such factors. Thermodynamics plays a crucial role in storm development. It governs the transfer of heat energy within the atmosphere. Warm, moist air rises, cools, and condenses, releasing heat and fueling storm clouds. Fluid dynamics explains the motion of air and water within a storm. Pressure gradients and wind shear influence the intensity and movement of storms. Understanding these physical principles is vital for predicting storm behavior. When the ocean rises, storm surge and the power of water. Storm surge is a dangerous phenomenon associated with powerful storms like hurricanes. It involves a rise in sea level caused by a combination of factors. Low atmospheric pressure at the storm's center allows the ocean surface to rise. Strong winds push the water towards the shore, exacerbating the surge. Storm surge can cause catastrophic flooding in coastal areas. Understanding this phenomenon is crucial for coastal protection and evacuation planning. Electrifying the skies. Electromagnetic forces and lightning. Lightning, a spectacular display of nature's power, results from electromagnetic forces within a storm. Ice particles within the storm clouds collide, creating static electrical charges. The separation of charges creates a massive voltage difference. When the voltage difference becomes large enough, it discharges as lightning. Lightning can be dangerous, causing fires and power outages. Understanding its formation helps us stay safe during thunderstorms. Indra's wrath. A glimpse into ancient mythology and storms. Ancient cultures often attributed storms to supernatural beings. In Hindu mythology, Indra is the god of thunder and lightning. He is depicted wielding a thunderbolt, symbolizing his control over storms. These myths reflect the awe and fear that storms inspired in our ancestors. While we now understand the science behind storms, these myths remind us of their power and unpredictability. Understanding the elements. Why these theories matter. Understanding meteorological theories is crucial for predicting and mitigating the impacts of storms. These theories provide the foundation for the models and simulations that meteorologists use to forecast weather patterns. By analyzing data from satellites, radar, and other sources, scientists can predict the path and intensity of storms, giving communities the information they need to prepare and stay safe. Accurate weather forecasts save lives by providing early warnings for severe weather events. When people receive timely alerts about approaching hurricanes, tornadoes, or blizzards, they can take necessary precautions, such as evacuating, securing their homes, or stocking up on essential supplies. This proactive approach reduces the risk of injury and loss of life. Knowledge of climate science helps us address the challenges of global warming. As we understand more about the factors driving climate change, we can develop strategies to reduce greenhouse gas emissions and transition to renewable energy sources. This knowledge empowers individuals, communities, and governments to take action in combating climate change and protecting our planet for future generations. By understanding the physics of storms, we can develop better building codes and infrastructure to withstand their force. Engineers and architects use this knowledge to design structures that can endure high winds, heavy rainfall, and other extreme weather conditions. This not only protects property, but also ensures the safety and resilience of communities. Finally, appreciating the interconnectedness of the atmosphere fosters a sense of responsibility towards our planet. Recognizing how our actions impact the environment encourages us to adopt sustainable practices, such as reducing waste, conserving water, and planting trees. These efforts contribute to the health and stability of our atmosphere. By studying and respecting the elements, we can strive to live in greater harmony with nature. This harmonious relationship not only enhances our quality of life, but also ensures that we preserve the beauty and resources of our planet for future generations to enjoy.